at the University of Florida. His research interests includes optimization and decision-making under uncertainties, Markov decision processes, and dynamic programming and applied probability. Dr. Tan will be conducting a workshop on Excel Solver. Dr. Tan, please.
Okay, thanks for the introduction, and thanks to everyone for joining us on this Saturday morning. We also definitely want to thank Prof. Napat for the wonderful sharing. And what I'm going to do essentially is that I would just make use of Prof. Napat's example, and then I will illustrate how we can actually solve this using Microsoft Excel. So I believe Prof. Napat has already highlighted to you how you could manually try to run through the set of feasible solutions. And in fact, we are not even running through all possible feasible solutions. We are in fact just running through the potentially good ones, which he has highlighted. You just kind of need to focus on the extreme points over there. Nonetheless, that you could see for a two-dimensional type of problems where you have two variables, that problem could be visualized, but it could also start to get a bit tedious to solve. Your number of extreme points start to get large. Once you get into three-dimensional type of problems, you have three variables. That's where you need to be able to visualize things in three dimensions. And once you get further than three dimensions, then I think most people will struggle to visualize what the whole visible set is going to be. As mentioned by Prof. Napat, there have been a lot of algorithms that have been proposed to solve such problems. And these algorithms, they have actually already been implemented by various types of software as well. So you could do it via Python. You could, in fact, there's a lot of libraries. If you do see, there are going to be libraries that are written in terms that optimization libraries that are written for the C language. There are libraries written for Java and so on. Okay, but I think for the sake of our event today, let's work on Microsoft Excel, which is probably the most straightforward for most people. I like it because what you see is what you get. You change the values and basically the calculations would automatically appear over there for you. Okay, so let's do that. So that's the aim that I have, which is let's quickly run through a quick example that Prof. Napat has shared with us. And let's take a look at how Microsoft Excel would then be able to solve that problem without us manually running through all the various extreme points. And so let me just share my screen over here. So this is the one. Okay, and so you should be able to see my screen over here. So let me just use my my whole screen just so that I can highlight the Prof. Napat's example and how we can put it onto Excel. Okay, and then once I think we are back into Excel already, then I can blow it up back to the full screen. So I hope that it's not too small. I hope everybody can see it. If there are issues, do let me know. Okay, but let's go with the example regarding the postman assignment over there. So this is a very real problem, right? Which means that you don't want to have your postman working for more than 7 days in a week. So in fact, depending on the country that you're operating in, there are going to be labor laws. So requiring sort of like the longest consecutive period a person can work and so on. So these are some of the considerations that companies do have to make when they perform their scheduling. And so here we're trying to see what is going to be the minimum number of people we can hire in order to meet the demand of various days. And so what we can do, as mentioned just now, when you think in terms of optimization problems, there are going to be three things that you want to look at. First, you want to think to yourself, what are the decision variables? Which means what are the decisions that SingPost would have to make over here? And how we have framed this problem was essentially the number of postmen that we are going to be hiring to start at Monday over there. So you realize that X1 over here is basically the number of postmen who will start on Monday and work all the way to Friday. And X2 over here are going to be the number of postmen that start on Tuesday and work all the way to Saturday and so on. Okay, and so we have X1, X2 all the way to X7 over here, where X7 is the number of postmen that begin on Sunday and work all the way to Thursday. So that is the decision that we need to make. We need to make 7 decisions. How many postmen to start on Monday, how many postmen to start on Tuesday, and so on. And so I believe you would have received this Excel template already. And so just to make life easy, I basically just come up with a template. All these are basically just normal text entry. So you don't have to worry about it. But the template over here basically is just a nice structure so that you can easily follow along my example over there. Okay, and so over here, we want to put in the number of postmen that are going to start on Monday, number of postmen that are going to start on Tuesday, all the way down to cell B8 over here, which is the number of postmen that are going to start on Sunday. But we're not done yet, right? So those are essentially the decisions that we need to make. So what are we trying to achieve over here? What is going to be our objective? So our objective essentially is that we hope to hire as little employees as possible in order to meet the demand. So our objective over here is basically the sum of the number of postmen starting on Monday, Tuesday, all the way to Sunday over there. In fact, that was given in the subsequent slide, right? So this over here, essentially, it's going to be your objective. And the last part of our optimization is that we need to kind of define the constraints. So if I didn't have any constraints, then the optimal solution would be obvious, right? Which means don't hire anybody. Then basically I would have found the optimal solution where I don't have to pay any labor costs. But obviously that's not going to be a feasible solution because there's going to be the manpower requirements over there. Okay, so that is given by all these constraints over here, where it's going to be x1 plus x4 plus x5 plus x6 plus x7 should be bigger than or equals to the requirements in terms of the number of people required in Monday, and so on for Tuesday and so on. So I believe Prof. Napat has discussed this already. Let me not reinvent the wheel. Yeah, but if you have any questions, feel free to just type them into the chat box, and then I will be happy to address them. Okay, and so for the committee as well, because my questions are on the other screen. So in case there are questions that were raised, I didn't address them, just sound out to me so that I will take note of that. Okay, but later on, once I move solely to my Excel spreadsheet, I will be able to bring my chat box back up. Okay, so with this, let us now go for one concrete example, right? So as Prof. Napat said that this E1 to E7 over here, the manpower requirements from Monday to Sunday, these are not your decision variables. These are in fact the problem given to you by, let's say, your management, or let's say by your HR team over there, or perhaps by your operations team. In fact, not the HR team, but by your operations team, right? They will say that, okay, based on historical demand, we're probably going to need, let's say, 2 postmen on Monday. So let me just say 2. So I need 2 postmen on Monday, and let's say I need 2 postmen on Tuesday as well. And then Wednesday and Thursday, let's say it starts to get a bit busier. So maybe I need 3 postmen on Wednesday, 3 postmen on Thursday. And then let's say when you go to Friday, that's where things start to pick up. Then I need 4 people working on Friday. And then once I get to the weekend, basically it dies down again. So let's say I need 2 on Saturday, and let's say I just need 1 on Sunday, where actually I don't even deliver, but basically I just need somebody to help do some post-admin over there. Okay, so obviously these are just numbers that I've just shoot out. You're free to just put in any other numbers over there. But this is just to give this problem some specific numbers. And then we will look at how Excel would then allow us to go ahead to solve this over there. Okay, and what we need to do is that we also need to explain to Excel the constraints, right? So as Prof. Napat said that, why are we interested in coming up with a structure like this? We're interested in coming up with a structure like that so that I can communicate this optimization problem to other operations researchers, to, let's say, my scheduler, or also at this point in time, for me to be able to communicate this problem to Microsoft Excel. And so I need to communicate the problem to Microsoft Excel so that Excel can solve the problem for me, right? So how do I communicate this to Microsoft Excel over there? So basically over here, I already have the right-hand side of my constraints are defined. Must be bigger than or equals to E1. Here I say E1 is going to be 2. So the next thing I need to do the left-hand side. The left-hand side, basically, if you look over here, I'm just saying that it is the sum of x1 plus x4 plus x5 plus x6 plus x7. So I'm just going to assume that everybody is new to Excel. So let's do this the most primitive way. Just type an equal sign over there, and then go ahead and click X1, and then you can press a plus button, and then go ahead and click X4, press a plus button, plus X5, plus X6, and plus X7. If you're familiar with Excel, you're well versed with functions, copying and pasting, absolute, relative, referencing, and so on. You can do it more efficiently. Okay, but let's do it the easiest, most straightforward way. Press the equal sign, and then after that, just add x1, x4, x5, x6, and x7 over here. Okay, and once you're done, then just go ahead and press enter. Okay, obviously at this point in time it's 0 because all my decision variables are 0 at this point in time. Okay, if I was to just change x1 to 1 over here, then you realize that Excel would have already updated that value. So this is what I mean by Excel being what you see, it's kind of what you get. So many people find it easy to use. Okay, let me take a look. I'm assuming there are no questions. So very quickly, let us just do the same for Tuesday all the way to Sunday as well. Okay, and so if you know how to do it, you can just pin on ahead. Let me just illustrate this as well. So for Tuesday, it is basically just x1 plus x2 plus x5, x6, and x7 over there. Okay, let me see. I got all 5 of them in. That's good. And then for Wednesday, it's just going to be x1 plus x2 plus x3 plus x6 plus x7. X4 is just going, E4. Thursday, basically, I'm just going to have x1 plus x2 plus x3 plus x4 plus x7 over here. And then for Friday, it's just going to essentially be x1 all the way to x5. Okay, like I say, if you're familiar with Excel functions, rather than doing it this way, you can just say sum up these 5 cells as well. If you do not know, if you're not familiar with the functions, don't worry, you don't have to use it, right? You can just go ahead and say x1 plus x2 plus x3 all the way to x5. Okay, either way, it's essentially just going to work over there. Okay, and so you can see from here, I basically just sum up x2 to x6. And for Sunday, I basically just sum up x3 to x7 over here. Okay, and then that essentially I would have defined my constraints. Okay, and so basically the constraints are now kind of defined. I've already set aside the cells for my decision variables. And basically now I would have set aside the cell for my objective function as well. Okay, and so the problem that has been expressed over here has already been expressed over here as well. So the next thing that we need to do is that we just need to get Excel to go ahead to solve this problem. One point to note over here is that there's an additional constraint that my x values over here are bigger than or equals to 0. So later on, I will illustrate how we will be able to add this into our solver. Okay, and so with that, I think now that we've transferred our entire problem over here, we are ready to just focus on our Excel spreadsheet. So let me just readjust my desktop. Okay, and so how we're going to get Excel to solve this, it's essentially we need to bring up this tool over here, which is going to be called Solver. So under your data tab, there's going to be this tool that is Solver over there. This comes along with your standard Excel package, but it is by default not sort of like activated at the start. So if you come to your data tab and you do not see the solver over here, what you want to do is you want to go to File, and you want to come under, let's take a look, Options. Okay, go ahead and click Options. And under Options, there's going to be Add-ins. Okay, then we go ahead and click Add-ins over here. And under Add-ins, there's going to be a Manage Excel Add-ins. Go ahead and click Go over here. This is where you will be able to see the add-ins that you're able to add. So if you do not see solver, basically what it means over here is that your solver, probably there was no tick over there. Okay, so let me deactivate my solver just to illustrate what it looks like. Okay, and so this is where this is probably the situation that you're in. Okay, you click on data, you realize under analysis, there is no solver over there. So what I want to do, let me reiterate my steps again. Let's go to File and come to Options. And then under Options, look for Add-ins. And in my version, I'm using Excel 365. There's going to be this Manage Excel Add-ins over here. And so this is where you click Go. Obviously, if you use a different version of Excel, your interface might be different. But how you look for it is the same. Just go for Files, go for Options, look for Add-ins over there. Okay, just go ahead and then look for my solver add-in. Let me just add it in. And you just need it to activate. And so just give it a while. Okay, and then you're going to see that solver is going to appear over here. Okay, and so once you have solver over here, what you want to do next is that you want to then click it to bring it up over there. Okay, and you are going to see this dialog box. So what I have, so actually at this point in time, what we have done is that we have basically just transformed that problem, that mathematical optimization formulation into my Excel spreadsheet over here. Okay, the next thing that I need to do actually is I need to convey this problem from Excel to Solver. That means I need to tell Solver essentially what are the cells containing the objective, what are the cells containing the decision variables, and what are the constraints over there. Okay, and so this is where Solver, under the Solver dialog box, you're going to realize they're asking you, what is the objective? Okay, the objective over here, in this case, if you're following my template, is going to be at B11. So click on this to activate this text box over here, and then just click on your B11. That should appear over there. Alternatively, if you were to just manually type B11 over here, that is also going to work as well. Okay, but let me just do, you realize that this is highlighted, okay? So that's going to work as well. Let's take a look. This problem, are we maximizing, minimizing, or are we targeting some value? We're minimizing, right? Because we want to minimize the number of postments. So let's minimize our objective value over here. Recall objective value is essentially going to be the total number of postments over there. And so this is where I realized that I have skipped one step. I realized that I have not put my formula for B11. If you click solve now, they will probably just give you an error message. Let's take a look at it. Yeah, it says that problem to solve is not specified because I have not put my formula into my B11 cell over there. Okay, and so what should my objective over here be? My objective, if you recall from just now, it is just x1 plus x2 all the way to x7. If you're familiar, you can just use the sum function. It is the sum of cells B2 all the way to B8 over there. Okay, but with that, we would have now done all the formulas that are required. So my cell B11 would now be containing the objective and the function has already been defined. I want to minimize it. That's why I select this minimize over here. Which are the cells I want to vary? I want to vary cells B2 to B8. because that's where my x1 to x7 are. Okay, the technical term that we typically use in the optimization community is that we refer to these as decision variables. Excel refer to this as basically changing variables. Okay, but essentially they're the same. The next thing that we want to do is we want to define our constraints. So let me just bring this down a bit over here. And so to add the constraints, basically just click on this add term over there. Okay, so let me just add which are the constraints I want to add. I basically want to add these constraints that I defined over here. So recall under column B, this was basically the number of people that are working on Monday. And so who are the people who are working on Monday? The people who are working on Monday, previously we've defined it as the number of people who has started working on Monday and at the same time started working on Thursday, Friday, Saturday, and Sunday over there. Okay, and so this was what our formula for D2 is. Same thing for D3 all the way to D8. And so that's what my left-hand side is. And I need my left-hand side over here to be bigger than or equals to my manpower requirements for each of the days. And those are given in column F. And so basically, I just go ahead and highlight columns F2 to F8 over there. Okay, I hope I'm not progressing too fast. Anyone with any questions, feel free to just highlight that to us. Okay, but once we are done with this, I can just go ahead and click OK. And you would observe over here, there is this make unconstrained variables non-negative. So this was essentially the constraints that Prof. Napat was saying, right? That highlighted to us as well, that our x1 to x7, they should be bigger than or equals to 0. So by checking this term over here, you are telling Excel that you want your x1 to x7 to be bigger than or equals to 0 as well. Okay, and so we're done with that. Finally, they ask you choose a solving method over there. And so here we're going to use the simplex LP. So why we use simplex LP? LP stands for linear program. And that is because our constraints over here are all linear functions. Our objective over here is also a linear function as well. So this is an entirely linear problem. As mentioned by Prof. Napat just now, that once your problems are linear, then in terms of the feasible solution space, that's going to have some nice mathematical properties. In fact, the fact that your objective is also linear, if you recall that you're just going to be looking at one straight line that you want to move as far possible northeast as possible to find the optimal solution. So the fact that your objective and your constraints are linear does make the solution somewhat more straightforward. And so then we can use more specialized types of algorithms to solve these type of problems. If you don't have this linear structure, then there are going to be other algorithms that you can call for. For example, if you have a non-linear type of structure, you can use your GRG non-linear. But that is not going to be as efficient because basically then you are just having a more generic type of approach, which in terms of performance would actually lag. So if you have a linear problem, just go ahead and select simplex LP. So as mentioned, to solve linear problems, there are going to be many possible type of solution approaches. Simplex is one of these algorithms, and that's the one that has been implemented by Excel Solver over there. Basically, simplex just runs through, it runs through the extreme points of your solution set, but it doesn't do it in a very haphazard way. It does it in an intelligent way, such that it doesn't have to run through all your extreme points, but it approaches it in a smart manner, recognizing in this particular situation that you want to move up to your northeast direction over there. Okay, and so taking into account the objective, you know what direction you are heading, and so you are able to just traverse those extreme points to find that ideal one. Okay, and so I hope that gives you an appreciation as to why the mathematical structure would affect sort of like the efficiency of the algorithm that you're looking at. The more that you know about the structure of the problem, the more efficient you are able to kind of go ahead and solve it. Okay, but probably we have digressed. The key over here is to recognize that it is a tedious task to run through these extreme points, even by using the simplex algorithm. Okay, and so the nice thing is that we already have this solver algorithm that's implemented for us, that we can just go ahead and use it. Okay, without further ado, I think the last step that you need to do is just go ahead and click solve, right? So probably some of you have already gone ahead and done it. So let's take a look at what is going to happen, right? So let's go ahead and click solve. Okay, and then it says that I found a solution, all your constraints and optimality conditions are satisfied. Okay, and so it's telling us that basically we have met all our manpower requirements over here, defined by our constraints. And at the same time, it tells us that this value over here is indeed optimal. Okay, and so under this situation, let's just say keep solver solution, and then let's just click that OK over there. And so basically, this is the solution that's given to us. Get 2 staff to start work on Monday. So they will work on Monday, Tuesday, Wednesday, Thursday, and Friday. Get 1 staff to start work on Tuesday, and then get 1 staff to start work on Friday over there. Okay, and that means in total, I'm going to need 4 staff. And basically, you're going to observe over here that basically this is then going to satisfy my manpower requirements that initially I have stated over there. Do we have slack in some of the days over there? Yes, we do, right? So that means on Tuesday, I only need 2 manpower, but it turns out that I have a total of 4 people working over there. Okay, this is something that is unavoidable in the real world. Okay, you need people to work 5 consecutive days, and then this is your manpower requirements over there. Unfortunately, there's going to be some slack over there. Okay, so this, however, is going to be the smallest number of people that you need to hire in order to be able to do this. Okay, so you can go ahead and try to solve this problem using 3 staff. You are not going to be able to do that. Okay, and so that's the beauty of Excel solver over here, or that's the beauty of optimization, which is that you can quickly identify what is going to be the best way to go about to execute these operational decisions that you need to make. Okay, so I can confidently tell my boss that, my boss may come and ask me, hey, am I allocating too many people? Because Tuesday I only need 2, but then I have 4 people over there. Okay, but because of this problem structure, this is essentially the best we can do. Okay, there's no way I can hire 3 people and meet these requirements that you have over there. Okay, so that's a quick run through of the Excel solver. But very quickly, let me just highlight one point to you over there. So then let's just try another quick example where let's say I only need 1 person on each day. What is then going to be the optimal solution? Anybody can see, right? Basically, I need 2 people, right? So I can't do this with 1 person. 2 person, I can definitely easily cover this. Okay, so let's get solver. Let's go ahead and click solver again. Your parameters should all still be there, so it should be fine. You can do a quick check. Objective is this, minimizing. My variable cells are these, and my constraint is this. I go ahead and click solve. What is going to happen? It's going to tell me that, okay, so the optimal solution is going to be that I hire 1/5 of a person on Monday and hire 1/5 of a person on Tuesday, and so on all the way to Sunday over there. Okay, and why does it tell me this? Because then my objective is going to be 2, right? So that's fantastic. It's going to be 1.4. So 1.4 is less than 2. So that's why Excel tells me that this is the optimal solution over there. Unfortunately, that's the problem with machines, right? Which is that they assume that you can just chop up a human into 5 pieces and then get 1 piece to start work on Monday. Okay, so what you need to do over here, if you realize that and the constraints are all met, okay, there's no issue mathematically speaking. So, but what happens over here is that essentially if you realize that your final solution, you need it to be integer. And in this case, it's not. So solver does have another inbuilt constraint that you can do as well. So what you want to do is come back to your constraints over here, click on add, and basically I say that I want my decision variables over here to be integer. So select this to be integer. Okay, go ahead and click OK. And then just go ahead and solve it. Okay, then under this situation, Excel solver is going to constrain it such that basically your decision variables over here is going to be an integer value. One point to note over here, which is that if you have integer constraints, then the problem becomes computationally more challenging to solve. I don't think we have the time to go into the algorithm as to how it actually does it. Once again, there's a whole series of algorithms. Some are going to be more efficient than others, but let's not go into that. But what you need to do over here is basically you can actually highlight to Excel solver that you want your solutions to be integer, and they can do it for you. But given the additional complexity, what happens is you just want to take note that the optimality conditions are satisfied. Okay, so sometimes they may run for a certain while, and then they say that I found a solution where the constraints are satisfied, but the optimality conditions are not satisfied yet. Under that situation, what you want to do is you want to just click OK, and then go ahead and run solver again. What it does is that basically it's just going to take your previous solution and continue to search for an even better solution. Okay, and so when you see that the optimality conditions are not satisfied, just go back and run the solver again until solver basically finds that optimal solution. If you try to run your Excel for 5 hours and it doesn't give you the optimal solution, chances are your problem is not well defined. Okay, and so then it will be a formulation problem rather than sort of like Excel having an issue to solve it for you. Okay, so that is essentially a quick run through of Excel, how it can be used to solve the problem that Prof. Napat has shown you. And basically, I've just highlighted a few key points that you need to take note of. Do we have any questions or anything that requires further clarification? I'll be happy to address them if any. I don't see any questions. So if there are no questions, then I will hand back to the committee and then the committee can take over from there.
Thank you, Dr. Tan, for the sharing. Now we'll move on. Due to the overwhelming response, we have decided to extend the deadline for signups to 16 February. So if you have friends who are interested in participating in BACC, do let them know. On Instagram, we're having a Grab voucher giveaway. To stand a chance to win $10 Grab vouchers, tag 3 friends who are interested in BACC in the comments and share this post on your story and tag us at NUSISE with the hashtag NUSISE BACC along with your team name. With that, we have come to the end of the workshop. Today's workshop has also been recorded and will be released to the participants for reference by the end of the day. If you have any queries, do reach out to us on Telegram. Do follow us on Instagram and LinkedIn to keep up to date with the latest BACC and NISE news. Thank you and goodbye.